Okay, I did my project on chapter 18, circuits, and the question that I did was question 52. Okay, so below you can see a series circuit, and the question has 3 parts, so I'm going to break it down into the 3 separate parts. So we're going to start with part A, and part A is find the equivalent resistance between points A and B for the combination of resistors shown. So in order to do this, I just kind of split it in half. I did part A as the bottom half and part B as the top half. All right, so looking at part A, our resistors 4 and 8 are parallel. So what we're going to do is we're going to multiply them and then divide it by the sum. And that's going to give us 2.67 ohms. But anytime resistors are in a series, so meaning they're right next to each other, all we have to do is add them together. So then all we have to do is take 3.3 ohms and then add it plus what we just got was 2.67 ohms, and we get 5.97 ohms for that part of the resistors. So moving to the top part of the resistors, like I just said, anytime resistors are in a series, all you have to do is add. So the top part is really easy. We're just going to add 2 and 1 and get 3 ohms. And then we are going to, since the top and bottom part are parallel, we're going to take the current from both, so 3 and 5.97, and we're going to multiply them and then divide it by the sum once again, like we did in the first half, and you're going to get 2. And if you can see, there's 1 ohm still left, and it is in series with the entire circuit, so all you have to do is add. So our total resistance is going to be 3 ohms. All right, so part B. Part B is an 18-volt EMF is connected to the terminals A and B. What is the current through the 1 ohm resistor connected directly to the point A? Okay, so we really just found our resistance, and in order to get current, all you have to do is divide voltage by resistance. So they gave you the voltage, which was 18 volts, and all we have to do is divide it by the resistance of the series that we just found, which is 3, so we're going to get 6 amps. All right, and now for part C. So part C is what is the current in the 8 ohm resistor. So the 8 ohm resistor is all the way down in the bottom. All right, so the first thing that we're going to do is we're going to do the same equation that we just used to find current, but we're going to rearrange it to find voltage. Okay, so this 6 that we just got right here is the current that we're going to use, and this 2, I will show you where it came from. Okay, so this 2 actually came from right here whenever we combined both sets of resistors, and we got this 2. We have not added in the 1 yet, so this is where the 2 is coming from. Okay, so we did 6 times 2, and we got 12 volts. All right, so now we're going to find the current. So we're going to take that 12 volts that we just got, and we're going to divide it by whenever we found the resistance of the first circuit. So I'll show you again. Here it is right here, 5.97 ohms. That's whenever we did the parallel, and then we added it with the 3.3. So we're going to do 12 divided by 5.97 ohms, and that's going to give us 2. And then we're going to take that 2 and multiply it by 2.67. And we got 2.67 from whenever we just did 4.0 times 8.0 divided by their sum. And that's going to give us 5.34 volts. And in order to find the current of just the 8 ohm resistor, we are going to do that voltage divided by 8, and it's going to give you 0.67 amps. And that's it.